Help me, they are trying to kill me. Use your eyes. Do not trust the mole.
What's going on, guys? FiberFlet here, and welcome to Methods and Objects. This is our fourth episode in our Java tutorial series. You could argue that this is going to be one of our most important episodes. This episode is going to be very code heavy, so get your popcorn, put on your programming socks, and get ready to go. The presentation section of this video is going to be a bit shorter than usual, but that's all right, because really the core understanding of methods and objects in Java really does come from programming. There's so much that I can describe to you when I really just need to show you like how to make methods and how it works in actual programming and code. So the first thing I want to talk about is what we're going to do today. We're going to make our own FiberBot object. We're going to be we're basically going to make a child object of the Karel J robot object in this episode called FiberBot. We're going to be adding more methods to increase the functionality of the Karel J robot robot class. And let's talk about the methods that we're going to do. So first, we have to figure out, how do we make a method? So the way we're going to do that is, first you have to say if the method is private or public. A public method basically means that if our program uses this like Java file, this object, those are the methods that it would have access to. So think of Karel J robot. When we make a robot object, we have access to like turn left and move. Those would be example of public methods that Karel J robot has. A private method is a method that only the like object itself has access to. I'm sure Karel J robot has a bunch of other private methods that we don't see. Mainly the private methods would probably be updating like the visuals of the Karel J robot world and like how his sprite turns and stuff like that. Stuff that basically the user, or in our case the programmer, won't need to see or have access to have the functionality of the object. The return type, you have to specify if this method is going to be returning a value. For instance, if we were making a method that adds two different integers, the return type would be int, because we're going to add the two integers and then return that value. If we're not returning anything, we just set that as void. That's the term used for a method that doesn't have any return values. And then we have the parameters. So if we continue with our example that we said earlier of a method that adds two integers, our parameters could be int a, comma, int b. And basically those variables will be passed into our method. And then we can simply have returned a plus b, and then that would give us our value. If we need a Karel J robot example of that, when we make a Karel J robot object, all of the parameters that we have for him, like int street and avenues and beepers and direction, those values are the parameters of the Karel J robot object. Now I just want to highlight the methods that we're going to make in this video. We're going to add a turn right method to our FiberBot. We're going to add a move method that takes in a parameter of int spaces. That'll basically make Karel J robot move the amount of spaces that we pass as a parameter. So our next method is public, a north, south, east, or west clear. This method will basically tell if the north, south, east, or west side of Karel J robot is clear. Public void empty beeper bag is simply going to empty all of the beepers that our FiberBot has. And finally, we're going to have a private method that's going to be called face north, south, east, or west. We're going to use, I just want to showcase how private methods work. This method is basically going to make a robot face that direction, and it's going to be all private inside the program. The user would not really need access to this for the functionality that we're adding. So I just kind of want to showcase how private methods work. So that's all that we're going to go over about objects and methods. Like I said before, mainly like showing you guys the code really helped like you visualize how this actually works. This could be a very code heavy video, like I said before, and we're gonna go ahead and hop into the code section right now. All right, guys, so now we are in our BlueJ project. We're gonna go ahead and first make our FiberBot object file. The way we're gonna do this is we're gonna make a new class. We're gonna call it FiberBot. We're gonna go ahead and open that. We're gonna delete all of this generated BlueJ code. Before we do anything, we have to first make sure that we have Karel J robot imported into our Java file. We're just gonna do that by saying Karel the robot. Now, the first thing we have to do is we have to tell Java that this program is a child of robot. The reason we have to do this is we want access to all of the robot / Karel J robot methods. And the way we're going to do that is we're going to do extends robot. So that gives us access to like Karel.turnLeft, Karel.move, and all the other public methods that are accessible through URRobot. So we're making an object. We have to make something called a constructor. We haven't talked about this at all, but think about a constructor as basically what fully creates the object. It is technically a method, but not really. It's a special method. When we're making Karel J robot, when we call URRobot Karel equals new URRobot, that is us calling the constructor to create a new object. So what we're gonna do is we're gonna do public. The constructor is always called what our class name is. So in this case, our class name is called FiberBot. We're gonna have to pass in the 4 values that URRobot takes, which will be int street, int avenue. We're gonna do direction dir, and then we're gonna do int beepers. There we go. So that gives us the parameters for our FiberBot object constructor. Next thing we're gonna do is we're gonna do something called super. What super does is it tells us, hey, we're gonna take all of these values and just use the constructor from URRobot from our parent. For the most part, you'll do this typically in Java when you're making a child object, unless it has different variable types. But in our case, we're just going to be using URRobot, and we're just adding extra functionality, so we can just super this method. We just have to super our street parameter, our avenue parameter, our direction parameter, and then our beeper parameter. And if we did everything correctly, we can go ahead and compile this, and there is no errors because now this object file has a constructor. So I want to show you that this actually worked. We're gonna go ahead and duplicate our first Karel program right here because we're programmers. We love duplicating stuff. We're gonna call this just FiberBot runner because it's gonna be the Java file that's gonna be running our FiberBot. We're gonna go ahead and open this. We're gonna want to delete all of this, and we're just gonna go ahead and load a blank Karel world, which I believe it should be karelworld.txt. And now we're gonna see if our FiberBot actually works. We're gonna do this. We're gonna do it exactly like how we would make Karel J robot. We're gonna do FiberBot Karel equals new FiberBot. We're calling our FiberBot constructor. Our FiberBot constructor is being called right here, and this is just the variable / object type. We're gonna go ahead and start him at 4, 1. We're going to start him facing east, and he's going to have no beepers. So if we did everything correctly, if we run this program, as we can see, we did do it correctly because there's a little arrow right here showing inheritance in our BlueJ. It's showing that FiberBot runner is using our FiberBot object. So that's a good sign so far. We're going to go ahead and run this program after we compile it, of course. And as you can see, it worked. This may look like Karel J robot, but I promise you this is actually FiberBot. And yeah, he's facing east at 4-1. So we did everything correctly. You know, chat, I mean, YouTube audience, I'm gonna be right back. I gotta go. I'll be right back. Alrighty, guys. So now that we're back, we're gonna go ahead and write some methods. We're gonna first write the turnWrite method. So using our presentation from earlier, we have to first say if it's public or private. This is going to be a public method because we want to have access to it in other program files. We're going to call it void because it has no return type. And we're going to call it turnWrite. It has no parameters, so we're just going to leave that blank. And there we go. So the first thing, so all we have to do is we just have to call turn left 3 times because Karel J robot can only turn left, unfortunately. But if we call it 3 times, he's kind of turning right, you know? We're going to go ahead and compile that. We're going to go over to our FiberBot runner, and we should be able to call Karel.turnRight. If we did this successfully, if we run the program, Karel should turn left 3 times, thus making him turn right. And as you, what? Yes, as you can see, it did work. Sorry, I thought Karel was facing east. Okay, so for our next method, we're going to be making our move method that's going to take int spaces as a parameter, and it's going to make Karel move that amount of spaces. In our case, in Java, one method cannot have the same name as another method, or that's going to cause an error. However, if the methods do have different parameters, then it's totally okay. Basically, what that means is we're going to have a move method with our parameter of int spaces. That's going to mean that our FiberBot's going to have access to Karel.move and also Karel.move with a specified integer with the amount of spaces that is going to move. So basically, we're going to do public void move. We have to make sure that's the same name as the other one. It's this time going to have a parameter, which is going to be int spaces. And we're just going to do a simple for loop as we went over in the loop video. We're going to do I less than spaces, and then of course I plus plus. And we're just going to simply call move. And if this works, we can go ahead and compile that. Open up our Fiberbot runner. We're going to not have him turn right anymore. We're just going to go Karel.move, and then we're going to pass 5 as a parameter. Go ahead and compile all of those, run the program. And if it worked, we're going to see that Karel moves 5. And I also want to show that we still have access to the regular move command. If we don't want to specify anything, you should just move 1. So we're going to go ahead and show that real quick. And as you can see, he still moved 1. So that means we have access to both of those methods. So there shouldn't be any issues with like backwards compatibility of our Fiberbot. All right, guys. So now we're going to do our Karel.empty beeper bag. We're going to go ahead and make that method. We're going to do public void empty beeper bag. Now, remember from last episode, this empty beeper bag was a very long command. We actually did it in our wall Karel file. So if we go here, we can literally just copy this while loop and go ahead and throw it inside of our Fiberbot right here. We just have to remove the Karel part, and this should go ahead and work. Why? Because extends robot. There we go. Okay, so earlier I lied. We actually wanted to extend robot. So this is where the extension is important in Java. We were extending your robot there, which didn't have access to the any beepers and beeper bag command. When we really need to extend robot, we need robot to be our parent object rather than your robot, because we want to access this method. So that shows you that you have to be very specific in Java, and you have to make sure that you have the correct parent object to have access to their methods. So now that we did that, we're gonna go ahead and test it. We're gonna open up our bot runner. We're gonna make Karel start with 20 beepers this time. We're gonna do Karel.empty beeper bag, and then we're gonna make him move 2. So we're gonna go ahead and run this program. We're gonna see Karel empty his beeper bag if we programmed everything correctly, and they should move 2. And as you can see, we did do that. So for our next method, we're gonna do if the south, the less south, east, or west, whatever is clear. First thing we're gonna do is we're gonna make our private method. We're gonna do private void face east. That's gonna be our first one. We're gonna do a simple while loop. We're gonna do while Karel, while not facing east. We're gonna just have Karel.turn left. Simple as that. He'll eventually be facing east. We're just gonna turn left. And then we're gonna make these for the 4 other directions. We're gonna copy and paste this 1, 2, 3. And as you can see, we have errors because these do need to have different names or different parameters. So we're gonna do face north. We're gonna do north. Then we're gonna do if facing east. We're gonna do west. We're gonna put west again. And then finally, we have to do facing south. And there we go. So now we have these private methods. As I said before, the outside program, like if we went to Fiberbot runner right now and tried to call Karel.face east, that would not work. All right, guys. So now we're gonna implement our if east, west, north, or south is clear method. We have our private methods now, so we should be able to be good to go on this. We're gonna make a public. This is gonna be a Boolean. We're gonna have to return true or false with this method, and we're gonna do first if the east is clear or not. We're gonna go ahead and put brackets right here. So the first thing we're gonna have to do is we're gonna have to have our return Boolean declared. So we're gonna say Boolean clear. We're gonna have it default as false, meaning if nothing passes, then it's just going to return false. So we're going to have a return statement, which is going to be return clear. We have to always have a return statement. If you're working with if statements in Java in methods, you're always going to have to have a default return statement. If you don't, the program is going to error out because if it's not a void return type, you always have to return something. We're going to first do if Karel is facing east. So we're just gonna do facing east. We're not gonna have to move him if Karel's facing east. We're gonna go ahead and set clear equal to front is clear. We're gonna do an else if Karel is facing north. We're gonna go ahead and make Karel face east by calling our face east command. Then we're gonna do clear is equal to front is clear. I forgot our semicolon. We're gonna do clear is equal to front is clear. We're gonna also have to put parentheses. And then we're going to go ahead and make Karel face north again, just by calling face north. We're going to go ahead and make another else if. We're going to do else if Karel is facing south. We gotta be the same thing, so we can copy and paste this code. He's gonna face east. We're gonna check if the front is clear, and then we're just gonna do face south. And then finally, we need him if he's facing west. So we're gonna do else if he is facing west. We're gonna go ahead and make him face east. We're gonna take that and then do face west. So this is basically the main idea of what we're gonna be doing. That's our east clear method. We can go ahead and copy this and update all of this code for the rest of facing west, north, and south. I'm not going to do that, but if you guys really want to, you totally could. For the example we're going to do, we just need the facing east, the east clear boolean. So now we've done that, we have all of our methods complete. We're going to go ahead and use these methods to rewrite that wall Karel program. All right, so now that we are in our wall Karel program, the first thing we're going to do is we're going to make this object be a fiber bot. We're gonna do fiber bot equals new fiber bot. We don't need this wall height anymore. Actually, we can still use that because why not? That's kind of fun. That actually makes the program run very quickly, so we're gonna leave that. So we have while front is clear, Karel's gonna move up to the wall and then he's gonna turn left. We're gonna keep that the same. So this is where we're gonna really change our code. Now that we have that if the east is clear or not, we can go ahead and add this. Instead of doing this, we're just going to make a boolean. We're going to call this we can do while Karel dot east clear. We're going to call that method. So basically this is going to basically keep repeating this while loop's going to keep repeating while the east is clear. We're going to go ahead. We don't even need this if statement anymore because once the east is clear, sorry, we have to do while the east is not clear. So basically this program is going to continuously run while the east of Karel is not clear, which means he's going to climb up the wall, which means all we need in here is Karel.move. And then we're going to also have to increment our wall height variable. We're just going to do that by wall height plus. Other than that, the rest of this program is going to work. Oh, we can see this right here. This is Karel turning right. We can go ahead and call our Karel.turnRight method right there. Make sure we add our semicolon. And then for our wall height, this is going to stay the same. Actually, we can change that too. We can do Karel.move. And then we just simply pass the parameter as wall height. And then finally, why is this erroring? Because the value is not called that. We're not programming in Python. We can't put underscores. And then finally, we can call Karel.empty beeper bag. So as you can see, this made this program a whole lot shorter and a whole lot like the readability of this program is a lot more easy now. We can see what it does. So we can see that Karel's going to climb the wall as long as the east is clear. Then we're going to have Karel move and then we're going to have him turn right and then climb down the wall. We're going to have him move equal to wall height and then we're going to have him empty the beeper bag. So we did everything correctly. We can see that is pointing to FiberBot. So that means we did implement that correctly. And if all of our code for the methods in FiberBot is correct, if we go ahead and run this method right here, we should see that Karel climbs the wall. So far, so good. It's working. I'm very hopeful, guys. We're going to see him turn, move. Oh, no. All right, guys, so we're back. I found the error. We have an extra Karel move here. I'm not sure why. I assume that the while loop we had in wall Karel exited when he was just at the top. But if we delete that Karel move, this should work now. We're gonna go ahead and run the program. It's not an error with our method. That's a good thing. And if we see it, he should climb to the top now. He should move, and that still did not work. Okay, so I found the other error. Karel needs to turn right at the top. He needs to move. And then he needs to turn right again. So we might have deleted a little bit too much code when we edited it. But with this change, it should work now. Like I said before, we know that the methods we programmed in FiberBot were correct. So that's a good thing. That's a good thing. We always implemented our methods correctly. We just did some bad programming in the file. We go ahead and see. Yep. And there we go. Karel's going to empty his beeper bag right there. And as long as the program exits, we have successfully done it. And that's going to be our Karel J Robot method and object tutorial. Thank you guys so much for watching. I hope that this video wasn't too confusing. It's a lot of information to take in. Objects are very important. We're going to see them in the future episodes. I do need to say that we're almost about done with Karel J Robot. We might start making like actual just straight Java tutorial videos. which might be a little bit boringer, but honestly, Karl's kind of sneaky. We might be done with him. In the next episode, we're going to be covering, I believe, arrays and array lists. Those are new data structures that are very important. It's in our fundamental data structure that you're going to be using for the most part in your day-to-day life while Java programming. Once again, thank you guys so much for watching this video, and I hope you guys have a wonderful rest of your day.